Hi, I'm Peter Amstutz. I am CTO of Curie Corporation, a longtime developer on Arvados, and one of the founders of the Common Workflow Language Project. Today, I'm going to talk about why good data management practices are important, how they relate to running, reproducing, and sharing scientific data analysis workflows, and how we approach data and workflow management in the Arvados platform. Why care about reproducibility? Once you publish a paper, you're done, right? Well, no. Science is an incremental and collaborative endeavor. Having developed some findings, you may realize later that you need to study them further, or share not only your results, but your entire data analysis process with a collaborator or regulator so they can understand what you did. If you don't have a complete record of your computational analysis, it is impossible for others who are attempting to reproduce your work to be confident that they are reaching the same result by the same methods. But this is more than just a good idea. Recently, the National Institutes of Health in the United States issued a new policy on data management and sharing, arguing that good data management is the foundation for data sharing and reproducibility of results. In 2023, all NIH grants will be required to include a data management plan. Let's talk about some common ways that data gets managed and some of the problems you run into when you try to share your work with others. These quotes are made up, but they should sound pretty familiar. I just keep the data on my laptop. That way nobody else can mess with my work. I'll share the results when I'm done. This is a data silo. Your data is here, your colleague's data is over there, and maybe you share data by emailing files back and forth. This is also popularly known as data available upon request. If you need something, but your colleague went on vacation, well, hopefully you didn't have any deadlines coming up. You're also responsible for making regular backups. So if your laptop dies, you don't have anything to worry about. Right? Now, most institutions have people who are aware of these issues and have implemented some kind of basic centralized storage, which leads to our second quote. I use cloud here because cloud is cool, but most of what I'm about to say applies equally to keeping data on a POSIX shared file system like NFS. We're working in the cloud. Everyone has access to the S3 bucket, and if you need to find something, you can go ask Jane. She's the only one who has the whole directory tree in her head. You probably have some basic scheme to keep different users from stepping on each other. But unless you've made an affirmative effort to document what you have, if the person who put the data there is not available, you're going to have a hard time figuring out what you have a year later. On AWS, access control is a simple matter of writing an IAM policy, then attaching it to each user account, user group, or role, then updating the policy or creating a new policy every time you need to add or remove a project or collaborate on the project. Or you could give everyone access to everything and hope nobody changes something they were not supposed to. Finally, I hope you got your data organization right the first time because you are stuck with it. If you decide to reorganize the data later, file paths change, and any old references in documents and scripts are all going to break. Some more quotes. I edit everything in place. When I need to save something, I copy the file and call it something like .old or .old2 or .old3 or .new or .new2 or .final or .final2. Try coming back to this a week later. I don't know about you, but there's always a little voice in the back of my head doubting that the file named .final2 is really the one I sent out. This is even worse if we were talking about very large data files, like sequence reads, and you're making destructive changes like filtering. Keeping lots of copies around can be a waste of disk space, but if it's not clear which file is the original, nobody will ever be able to figure out what you did. But hopefully you do care about someone being able to figure out what you did. I keep track of my data analysis runs in a spreadsheet or lab notebook. The common theme in these anti-patterns is human error. If you're manually recording each step of your work, you're on the right track, but it's still easy to forget to write something down. Also, without some kind of versioning scheme, it may be hard to say which version of your code ran on which version of your data to produce a certain result. Scientific workflows are important for reproducibility because they encode all of the steps, inputs, and outputs that make up a data analysis. A workflow management system executes a workflow for particular input data in order to produce a result. Reproducibility requires, for a given result, that we know how it was produced. This is called provenance. The more detail, the better. This means precisely identifying the input data sets, workflow steps, software versions, hardware resources, and other details that will enable someone to later recreate a compatible environment that will produce the same results given the same initial inputs. We could try and record all of this by hand, but computers are good at remembering things, and workflow management systems already know all these things. On the other hand, data and code can change over time, so simply recording file names and paths isn't good enough. We need data management. I talked about some of the problems that come up with bad or no data management, so now let's talk about some requirements for good data management for your analysis workflows. We need to precisely identify the data sets and software versions that went into an analysis. Keep a record of what computations happened and connect it to results. We need to identify data sets and software at a point in time by assigning versions. We probably want multiple ways to find data: naming conventions, searchable metadata, and robust identifiers. Robust identifiers are important because they facilitate reorganizing data after the fact by continuing to point to the same data set even after it is moved or renamed. A special type of robust identifier is a content address. This is an immutable identifier derived by computing a cryptographic hash of the data set. One benefit of this is that if you have a copy of the data but are not sure what version it was from, you can figure it out by computing a hash. Content addresses are particularly valuable for reproducibility because changes in your input data or software environment either can't happen because resources are pinned to uniquely identified versions or are easily detectable when comparing two runs. Finally, because the goal is for other people to be able to understand and reproduce your work, we want our data management system to make it easy to control sharing with others. The Arvados team has been thinking about and working on this topic for a few years now. So now I'm going to talk about how we approach data and workflow management. Arvados is an open source platform sponsored by Curie for storing and organizing scientific big data and supports running common workflow language workflows on that data. It consists of two main components: a storage system we call Keep and a workflow manager we call Crunch. Arvados is multi-user and multi-platform and runs on various cloud and high-performance computing environments. It is used by small academic labs and innovative biotechs, all the way up to multinational pharma companies to build their own data lakes or data commons. In Arvados, a collection is a set of files grouped together that make up a data set. Collections are organized into projects. Each user gets their own workspace, but can easily share projects with others with a simple sharing dialog in the web workbench. This lets you avoid data silos. Collections and projects can have searchable metadata, making it easier for others to find data. Collections can be modified, but Arvados automatically keeps a complete history of past versions of a collection. Collections can be identified in the system several different ways. First is by content address, which is based on a hash of the collection's file contents. The content address changes if any of the files change. The second is by database UUID. Content addresses and database UUIDs are robust identifiers for the collection. You can safely reorganize a project hierarchy or move or rename the collection and have the robust identifiers continue to refer to the same collection wherever it ends up. The third is by human assigned names, which are unique within a given parent project. Collections can be very large, on the scale of multiple terabytes, but regardless of size, you can still identify the entire dataset with a single identifier and keep a version history of every change. When you submit a workflow, Arvados keeps detailed records of each workflow step run by the system. This includes the input and output collections, container images that provide the software environment, hardware resources that were requested, and logs of both the program itself and the program's resource usage on the compute node. Inputs and outputs are stored by content address. These are immutable identifiers of content. This means that reorganization and changes to collections do not break references. In the case of the collection changing, it will just refer to an older version of the collection. Arvados completely abstracts the underlying storage so you can run it on top of conventional file systems or cloud object storage. Arvados provides a variety of ways to access files and collections. You can download them from the web workbench, mount a collection as a Linux file system, or even use our S3 compatible API that prevents Arvados collections as buckets, enabling you to connect applications with existing object storage support to Arvados. Here's what a collection looks like on Arvados Workbench. For identifiers, we have the collection name, universally unique ID or UUID, and the portable data hash, which is the content address of the files in the collection. The database UUID always points to the most recent version of the collection. We also have metadata about the collection, such as where the data was collected, the file format, the species, and then at the bottom, if you were to scroll down a bit, a list of files in the collection. Here's what a workflow record looks like in Arvados Workbench. Each workflow run has a universally unique identifier. Workflow steps are run in a container, so we record the Docker image used for the run. We have links to the collections containing the input files and output files. Logs produced by the run, as well as metrics such as CPU usage, memory usage, disk usage, and network usage are all recorded for the entire run. Each workflow step is listed below, and clicking on the workflow step navigates to a similar page with the inputs, outputs, logs, and so forth for each individual step. Another aspect of data management we haven't talked about too much, but is a pretty big deal, are legal requirements from oversight agencies and regulators. In particular, if you're working anywhere near human data, you probably care a lot about security and access control. Some things that Arvados does to maintain security include requiring that all API endpoints require the client to present a secret access token which identifies a user, encrypting all traffic using TLS by default, and supporting data encryption at rest. Arvados supports various single sign-on systems, including LDAP, OpenID Connect, and Google accounts. Data uploaded to Arvados is private by default, but can be shared with other users or groups at different access levels. In conclusion, we built the Arvados platform to be a production-ready open source solution to difficult data and workflow management problems. If you would like to learn more, please visit our website at arvados.org. Follow the documentation link on the front page to get to the Arvados documentation, which includes our user guide, and if you think you would like to set up Arvados for yourself, our installation guide. Follow the community link on arvados.org to get information about the Arvados discussion forum, chat, video calls, and other community events. Curie has also set up a demo instance at playground.arvados.org where you can get a feel for what it is like to use Arvados as a regular user, including working with data and running CWL workflows. Finally, if you're interested in professional support and development services, including training on using common workflow language with Arvados, please contact us at info@curie.com for more information. Thank you very much for your time.